Right, this is 6th grade math, page, let me get the right page, page 175 in your books. Please follow along in your book. A lot of people have questions on things, and I'm finding as I'm watching some kids watch podcasts, they're not following along in the book, so it's really important that you do that because I refer to things in the book as we go through. So the vocabulary, this whole lesson is about the distributive property. And the distributive property is defined on page 175. It basically is best to show it in an example. So I'm going to pick some small numbers and show you the distributive property. The distributive property is used when a number is multiplied, okay, a number multiplied, maybe, multiplied to a sum or difference. So it would look, here it is with numbers. 3 times 4 plus 5, or we could do 5 times 7 minus 3. In both of these, let's look at the definition. The number is multiplied. This 3 is times, this means to times right here, 4 plus 5. That's the sum. This is the 5 is times 7 minus 3. Now, let's talk about 2 ways to solve this problem. You might think there's only one way because we've been talking about order of operations, and technically with numbers, this is the way I would solve this. But remember, we're practicing a new skill, which is the distributive property, so it's best to learn with numbers that we are familiar with and comfortable with so we can make sure we get the right answer. So the old way we would do this is we would add the 4 and the 5 because they are in the parentheses. And then we would take it times 3, which is 27. That's easy. It makes sense. This one, 5 times 7 minus 3 is 4, and 5 times 4 is 20. Now that's how we would do it normally, but today with the distributive property, here's how we're going to do this. So we're going to get rid of this stuff. And the distributive property means we're going to distribute the number, that we are multiplying into the parentheses. And since it's multiplying, we're going to distribute it with, let me just put over here the answer so we remember 27 and 20 because we're going to get the same answer. The 3 gets distributive, so I use these little arrows to remind me the 3 is going to go to the 4 and the 3 is going to go to the 5. We're going to distribute the 3 into the 4 by multiplying, and the 3 to the 5 by multiplying. So 3 times 4 is 12, plus 3 times 5, which is 15, and then you add those, and you get 27. And this comes in really handy in algebra when you don't know what one of those letters, if one of those letters is a variable. And that will come later on in your mathematical careers. So then this one, you would go 5 times 7, 5 times 3, and you would leave the minus sign. So 5 times 7 is 35. Minus 5 times 3, which is 15, and 35 minus 15 is 20. Notice we end up with the same answer. So, works out, I mean, it's a little different, but it works out the same, both the same answers, but this lesson I want you to practice the distributive property since that's what we're talking about. So there's a lot of stuff for you to write there. Make sure you put in the examples. It's nice to have an example. Actually, if you turn to page 176, why don't you do that right now? On page 176 is the key concept box. Sorry, my pin's freaking out on me here. The key concept box, you need to copy that over. You'll notice they have an algebraic. Let's just do the algebra one since I already did one with numbers. Let's see. You would take A times B, A times C. So that would be AB plus AC. And we can't multiply those obviously because we don't know what they are. If it was subtracting, it'd be A times B minus C, A times B, so AB minus AC. So there's the algebra, and we just did the key concept with the key vocabulary. So that works out good. And let's look at some examples. So example number 1, standardized test practice. Your class held a 2-day car wash. The class washed 40 cars on the first day and 30 cars on the second day. The class charged $5 for each car. Which equation can be used to find T, the total amount of money raised by the class? So notice on this equation, every time they washed a car, they got $5. So this is how many they washed the first day, this is how many they washed the second day. Well, they're only taking 5 times 40, so that's not enough. They have to also take the 5 times the, the 5 times the 30, so that one's out. Right there. Let me get my pin back here. So A is out. You don't just add how many they did. They did 70, but that doesn't tell you how much they raised. This one, look, they're subtracting, so this one would be $200 the first day, $150 the second day, but you don't subtract them, so B would be out. So by process of elimination, I say it's D, and notice D, there's your distributive property. You're taking 5 times, you could do this, 5 times 70 cars, because 40 the first day, 30 the second day, they washed a total of 70 cars, which would be 350. Or you could do this distributive property. It would be 5 times 40, which is 200, which we kind of did up there, plus 5 times 30, which is 150. So that would be 350. Same thing, just remember we're practicing the distributive property. So here's where they're taking it times, and this is what we just did. Or you could do it the distributive property, what we just did also, and get the same answer, 350. So the answer is D. Okay, so the guided practice, what if, I'm pretty sure there's a guided practice, what if, how much money would you raise by charging $4 per car? Well, remember 4 times the first day they did 40 cars, times the second day they did 30 cars. So we can take 4 times 40, which is 160, and 4 times 30, which is 120, add those together, they would make $280. So that's quite a bit less. By just taking $1 off, they lost $70. So, all right, this is very important. A lot of people miss these because it says to use the distributive property. I don't want to just see an answer, I want to see your distributive property. So I want to see you distribute the 2 into the parentheses, 2 times 50, 2 times 6. So I want to see 2 times 50 is 100, plus 2 times 6, which is 12, and that equals 112. I don't want to just see 112, I want to see the 100 and the 12, so I know you understand the distributive property on these problems. So let's see, there they are, taking the 2 times 50 and the 2 times 6. There's our 100 and our 12, 112. Okay, now decimals, just a trick when you're multiplying and you have a 0 on your number, like a 10, 100, or 1,000, numbers get bigger when you multiply. You just move the decimal one place to the right to make it bigger. Check this out, 86, remember how we learned to multiply last time, is just take the numbers. It'd be 86 times 10, which is 860, and there's 1 decimal place in the factor, so it would be 86. Well, look what happens when you move the decimal 1 place to the right. It is 86. And this one also 1 place to the right, because you're taking 10 times this, 10 times this would be 24. So 86 minus 24 is 62. They're showing that. And that right there is just a shortcut, right? You want to look for things that make your life easier when multiplying, so you don't have to write so much stuff out. To find 6 times 87, rewrite 87. It says evaluating using mental math. One way to think of 87 is to break it down. Instead of taking 87 times 6 and doing all that multiplying over here, take 87 and break it down into the tens and the ones. So 87 is the same as 80 plus 7. And we're taking 6 times everything, so you put parentheses around it, put the 6 on the outside, now take 6 times 80, 6 times 7. So 6 times 8 is 48, and add the 0, plus 6 times 7 is 42. So 480 plus 42 is 522. So by breaking down numbers into smaller pieces, you can evaluate them mentally. So look what they're doing. Well, I don't like the way they're doing that at all. Well, I don't like their method at all. See how we broke ours into, I think that's hard. Why would they do that to you guys? Sorry, see, this still equals 87, but gosh, I think it's easier to do 80 plus 7. So however you want to break it down, that's fine. They still get 87 right here, but I think that's confusing. Okay, so this one, same thing. I'll probably do it different than what they do. I'm going to break this down. 6.1, there's a 6 plus a 0.1. And remember in the last chapter when you were breaking decimals down, this is one of the reasons why. So 8 times 6 is 48, and 8 times 0.1, 1/10, is like 8 dimes, so it would be plus 80 cents. It would be 0.8. So 48 plus 0.8 is 48.8. Let's see if they're probably going to do it. Oh no, look, they did it our way. And they agreed with us. Yay! Okay, example 4, using a formula. The Hubble telescope orbited Earth at a rate of about 4.78 miles per second. How far did the telescope travel in 3 seconds? Okay, the formula that we're using in this is called the distance formula. The distance this is a very important, this comes up so often, and it's such an easy formula to remember, that your distance equals your rate times your time. And I always relate that to driving in my car. You know, if you're driving to Sterling and the speed limit is 65 miles per hour, that's your rate. You're traveling at a rate of 65 miles per hour for a half an hour or however long it takes. But let's not even say it's Sterling. Let's just say you get in your car and you travel at a rate of 65 miles per hour for 1 hour. How far will you be in 1 hour? If you're going 65 miles per hour, you're going to be a distance of 65 miles away from home. That always helps me remember the distance formula. Distance equals your rate times your time. Rate is kind of another word for speed, I guess would be a way to say it. So, wait, let's go back. They've given us the formula. Let's do it in this page. Distance equals rate times time. So let's see what they give us. You have a rate of about 4.78 miles per second. So that one's 4.78. And you're going to travel 3 seconds, so times 3. Now, you know, I don't know. Maybe I would use the distributive property here. I think it's a little bit harder. You can take 3, you can break 4.78 into 4 plus 0.78. Maybe not quite as easy. 4 times 3 is 12. And then this one you would just take 78 times 3, practicing what we've done with decimals in the first, 21 to 23. And there's 2 decimal places, so you're going to move it over 2 places, so plus 2.34. So I'm going to get 14.34. How far did it travel? And it's miles. So it traveled 14.34 miles in 3 seconds. So that's flat out moving pretty good. Okay, so let's see what they did. And they broke it down a little different. They broke it down into a subtraction problem instead of an addition. I think it's easier to do addition to break 478 up, but you're going to notice they're going to get the same answer. There it is. Good thing about math is there's more than one way to do things, and sometimes that's the bad thing about math is there's more than one way to do things. So using the distributive property right here, again, and mental math that breaks it down, you're just going to take 7 times 20, 7 times 3. So 7 times 20 is 140, minus, because there's a minus right there, 7 times 3 is 21. So that's going to come out to be 119. Okay. Now check out this one. This one's a little tricky. When you multiply, we have a decimal right here, but this doesn't. How many of you recognize that 0.5 is equal to a half? Okay? And what we can do when we're multiplying, instead of saying times, substitute in the word of. So instead of saying 0.5 times 24, listen to this. Think of this as a half and say of. 1/2 of 24. What's half of 24? That's like just taking it and splitting it into 2 equal parts. That would be 12. Plus half, that's half of 24, then half of 18, which would be 9. Remember, they want us to do mental math, so we're always looking for these shortcuts. So this half right here. Half of 24, half of 18. I know you have to recognize that that's equal to a half, but look at how much easier that is. Once you recognize it, you get 21. If you wouldn't have recognized it, you would have had to go 24 times 0.5. That'd be 0, carry the 2. That would be 12 with 1 decimal place, or 120 with 1 decimal place, so there's the 12. Then you would have to take 18 times 0.5, that's going to be 0, carry the 4, 9, put in the 1 decimal place, there's the 9. And see, we got that really, half of 24, 12, half of 18, 9. Boom, you're done. Makes it easier. So try to recognize shortcuts. That's a really good one right there to remember. 21. All right, so this one, again, I'm going to break this down into, I'm going to go 8 times 50 plus 3, that's still equal to 53, but I'm breaking it down into smaller parts. So 8 times 50, 8 times 5 is, and add a 0. And then 8 times 3 is 24. Is that a 400? Guess so. Boy, that's terrible. 424. And it's not just do the answer, it's break it down into the distributive property. Okay, so 1.4 breaks down into, that'd be 7 times 1 plus 0.4. 1 times 7 is 7. 7 times 0.4. 7 times 4 is 28. And there's 1 decimal place, so we put in 1 place. We add 7 plus 2 is 9, and you just bring the 0.8 with it. 9.8. So on example 4, what if the distance of the Hubble telescope traveled, find the distance it traveled in 4 seconds. So I got to go back to that example. Let me look. It goes 4.78 feet per second. So we need to take that times 4. So 4 times 4 plus 0.78, breaking it down. 4 times 4 is 16. 4 times, that one I can't do as fast. Carry the 3, 28, 29, 31. And there's 2 decimal places in 78, so I got to put 2 right here. So plus 3.12. And when I'm adding so fast, remember, this is a whole number and these are whole numbers. So what's 16 plus 3? That's 19. And then you just carry the decimal with it. So it's 19.12. All right? So they're going to be asking you to solve problems using the distributive property. If you have any questions, please ask. I don't want you to do this whole lesson and turn it in and find out that you didn't show your work the right way. So please ask if you're stuck, or watch the podcast again if you don't understand parts of it. And I think they're going to show us the answer, 19.12, which is what we got. So we're good to go. All right, that's it. We'll see you in 4.3. Bye.